Hello beautiful people and welcome. In today's video we're going to be reviewing all of our volume formulas for prisms, cylinders, pyramids, cones, spheres, hemispheres. The majority of these are going to be composite figures because in a composite figure we can review more of our volumes. So here I have kind of pre-written the formulas that we're going to need. I don't have the formulas in yet, but I do have the names and then the steps to solve for volume. Okay, so let's go ahead and review our formulas. Some of these are going to be similar, and you should know that they are similar. All right, let's go ahead and get started. Prism is volume is equal to the area of the base. I'm going to write A here times the height of the prism. Cylinder is very similar. Area of the base times the height of the prism. I'm going to go ahead and put an arrow here because we know what the base is of a cylinder, and that is a circle. So we're doing an area of a circle times the height of the prism. All right, next we have pyramid. So the formula for the pyramid is 1/3 times the area of the base times the height of the pyramid. Now remember, pyramid height, you want it perpendicular to the base and going all the way up to the vertex, not the slant height. Then we have a cone. Cone is, again, very similar. Area of the base, and then the height of your cylinder. Now this one deserves an arrow once again because we know what the base is. The base is a circle, so pi r squared. And again, we have the height of your cone. Sphere formula is where is it? There it is. I'm looking at my cheat sheet here just to make sure that I'm giving you the right formula, and I almost gave you the wrong one. 4/3 pi r cubed. And then for the hemisphere, again, all I'm recommending for the hemisphere is multiply by 1/2 or divide by 2 the formula for your sphere. So these are the formulas that you need to know. Usually we have you memorize these because they are so similar. Memorizing these formulas is not that difficult in my opinion, but again, that is just my opinion. Steps to solve for volume. I'm going to put this in a thinking bubble to separate them. Step number 1 is always identify what you have. Step number 2 is always write out your formulas. Step 3 is solve. If you are dealing, if you are dealing with composite figures, you need to know if you're adding them or if you're subtracting. Depending on if you are adding two figures together to form the composite figure or if you're taking something away from a figure. All right, let's go started with example number 1. I have pre-drawn this already. Go ahead, and my recommendation is pause the video, take a moment to draw this on your notes, and then come back to it with work already done. So step number 1 is identify what we have. I have a hemisphere. I'm going to write just hemi here, and then I have a cone. So again, hemisphere looks something like this. Cone looks something like that. So what do we need? Step number 2 is write out our formulas. Our formula is for a hemisphere, half of the formula for a sphere. For a cone, our formula is 1/3 area of the base times the height of the cone. Let's work with the hemisphere first. 1/2 times 4/3 pi radius cubed. Do we know what the radius? Yes, we do. We know the radius is 39. Stripe for the cone. Volume is equal to 1/3 area of the base, which is pi r squared. It is a circle, times the height of the cone. So we have 1/3 pi radius. Radius is 39 squared times the height of the cone. Now I'm going to pause for a second here because my initial thought was to make the height of the cone 81. But notice that the cone ends here. So this entire, from all the way to from the top all the way to the bottom is 81. But we don't want that. We only want this section here. So what is that size? I'm going to draw this out. A hemisphere is half of a what? It's half of a sphere. And what is a sphere? What shape is a basketball, a soccer ball, a baseball, a volleyball? A sphere is just has a shape of a circle. So on a circle, if I know the radius is 39, then the radius is any point on the circle to the center point has the exact same measure. So if this is 39, then this is 39, then this is 39. Here's 39 again. Here's another 39, another 39, and another 39. So that means that from the center point all the way down, that is 39 feet. Because that is 39 feet, above it is the height of the cone. So from the center point all the way up here, so what I'm doing to find the height is I am going to remove, here's my thinking bubble down here. So I'm going to say 81 minus 39 is going to be my height of my cone. So, okay, so what is 81 minus 39? That is 42. I'm going to bring that up here. That is 42 feet. And now I'm going to use my trusted calculator to find what the volume is. All right. Let's do this one first. I'm doing what's in the parentheses. So 39 cubed times pi times 4/3 divided by 2. And that gives me 39546. Fine. I'm going to round later. I have, what do I have? 39 squared times 42 times pi divided by 3. And this gives me 21294 pi. I'm going to combine them because these two are combined. So the total volume, again, using my trusted calculator, there's that one, and I'm going to add to it the other one, and I'm going to round. So I have about 191,134. What do we have for units of measure? Feet. What are we trying to solve? Volume. Volume is always cubed. All right, let's move on to our next example. I'm going to switch this up. Here's example 2 and example 3. Pause this video, go ahead and sketch them out, and that way you have them ready. Step number 1, always the same. Identify what you have. I have a cone and I have a cylinder. Volume formulas for a cone. We already know that from our previous example. Area of the base times the height of the cone. Volume for cylinder, area of the base times the height of the cylinder. 1/3 area of the base, we know the area of a cone is a circle, so that is pi r squared. Height of the circle, sorry about that. Area of the base we know is a circle in a cylinder, and we want the height of the cylinder. Let's plug some numbers in. 1/3 pi r, what is our radius? Our radius is 3. Height of the cone, do we know what this height is right here? Unfortunately, we do not. We do note that this side right here is 5. Let me zoom this in just a little bit. So if we know that, trying to find a colored marker. If we know that this radius right here is 3, then I also know that this radius right here is also 3. So that means in order to find the height, and again, the height has to be perpendicular to the base, I'm going to have to use the Pythagorean Theorem. Now, if you know your triangles, then you should already see that this is a special triangle. If you don't know that this is a special triangle, that's okay. You can always use the Pythagorean Theorem to solve for it. But what we have is 3 squared plus x squared equals 5 squared. So we have 9 plus x equals 25. I'm going to subtract 9. So what do I have? 15, borrow the 1. If you want to do that, if not, use a calculator. 25 minus 9, that should be what? 16. There should be a squared here. Square root of 16 is plus or minus 4 because we are talking about unit of measure. Units of measure cannot be negative. So we just have 4 here. Okay. Anytime you take a square root this way of x and try to solve, you do have a plus or minus in front of that value. But because we're talking about unit of measure, we're talking about the size or the height of this, that height cannot be negative. So then we have the height of 4 yards. All right, so we have all the information there. Let's continue to the cylinder. I'm going to zoom back out here. All right, pi, r, we said that was 3. Height of the cylinder is 5. Taking out my calculator. 3 squared is 9. 9 times 4 is 36. 36 times pi times our 1/3. And I actually rounded on this one. I have 37.6991. Let's do this one. 9 times 5 is 45. 45 times pi is about 141.372. Again, did we combine or did we remove? We actually combined, so our total volume is 179.1 yards cubed. And that's a 7. All right, let's move on to example number 3. In example number 3, we have this part shaded out. So I wanted to show you that this part is drilled out. So we do not have this cone inside of this box or this cube. All right, identify what we have. We have a cone and we have a cube. How do I know it's a cube? Because it's 6 by 6 by 6. All the measures are the same. Volume of a cube is s cubed. Or you can say length times width times height, or you can say the area of the base times the height. It's the same thing. Cone, what did we say? Is 1/3 times the area of the base times the height of the cone. Area of the base, we know it's a circle, so pi r squared times the height of the cone. So we have 1/3 pi. What is the radius of our cone? We don't know because it's given our diameter, but we know that a radius is just half a diameter, so it is 2 times our height of our cone, again, perpendicular all the way up, and that is 6. That looks like a B, but that is actually 6. All right, cube. Side cubed, so we have 6 cubed. That made it a little bit easier. Again, what are we doing? We are removing. What are we removing? We are removing the cone from the cube. So let's go ahead and solve this. 6 cubed is 216. Let's solve this one. 2 squared is 4. 4 times 6 is 24. 24 divided by 3 is 8. So I have 8 pi here. And I have 216. So I will round. Let's go ahead and combine. I know I have 216 centimeters cubed minus 8 pi. You can leave this as your answer and put centimeters cubed here. If you'd like to round, which we are going to do, you're going to need a calculator. So 8 times pi, that's about 25.13. So we're going to say 216 minus 8 pi. I'm going to round, and I get about 190.87 centimeters cubed. And again, how many decimals do you round to? Round to as many as they tell you to round, okay? Read the directions. Let's do one more. All right, what's happening here? I have a rectangular prism. I'm going to say prism 1. And I have another rectangular prism. I'm going to say prism 2. You can say prism big, prism small. Let's do prism small here. So that way we just know the difference. So let's do prism number 1, which is the big one. Volume is area of the base times the height. Or again, super duper easy for a rectangle, length times width times height. So we have 4 times 12 times 5. And then for the other one, we have again area of the base times the height. So length times width times height. So what's the length of it? It's 8. The width of it, this right here, is the same as this, which is the same as this. So we have times 5. And then what is the height? The height is 2. Are we adding them or are we taking away? We actually put another box on top of the original, so we are adding. So 4 times 12 times 5 plus 8 times 5 times 2. And I get a total of 320. What's our unit of measure? Feet. What are we trying to solve? Volume. Volume is always cubed. Ooh, my paper moved here. All right, let's move on to more examples. Let's do 2 more. Here is example number 5. In example number 5, we have 2 cylinders. So we have the larger one on the outside. Then this right here, this has been drilled out, okay? This has been drilled out. This, it's a little difficult to see, is the radius of the small, and this is the radius of the larger one. Just to be clear. All right, what do we have? We have cylinder. You can say cylinder, which is the bigger one, and then cylinder, which is the smaller one. Formula for a cylinder is exactly what we've used before. Cylinder is area of the base times the height of our cylinder. Again, for both. I know it's going to seem a little repetitive with you writing down the formulas all the time, but I guarantee you, if you write down the formulas all the time, you're less likely to make a mistake. Cylinder, we know the area is pi r squared. So what is the radius of your bigger cylinder? We said that is 4. What is the height of the bigger cylinder? That is 10. Smaller cylinder, that is 2 for the radius. Height of the smaller cylinder is still 10. Are we removing or are we adding? We are actually removing. So this right here, if you can see the arrows, that means the cylinder has been drilled out. So think of it like a paper towel roll. This is exactly what this would be. Let's do that. 4 squared is 16 times 10 is 160. So I'm going to say 160 pi for this one. And then I have 4 times 10, this is 40 pi. So this is one of those numbers that you actually don't want to round because this is pretty. You know, you get a pretty answer. So 160 minus 40, you get a total volume of 120 pi. Now, if you do insist on rounding and if the instructions insist on you rounding, 120 pi is actually equal to 376.991. So you can round it to, again, depending on what they want you to round it to. Ooh, the same thing twice. 377 inches cubed. Again, what are we trying to find? Volume, it is cubed. What are our units of measure? Inches. Make sure you have both of them. Like, to me, 120 pi looks so much better than this right here, the 376.991. And our last one right here. Again, what are we trying to find? Volume. What do we have? Here we have a composite figure, and we kind of have to decide how we want to split this up. I am going to choose to split it up this way. And then have this piece be the piece that's on top of it. If you choose the other way, your answer is going to be exactly the same, okay? But that's just how I'm choosing it. I'm noticing I have two prisms, two rectangular prisms. I'm going to say I have the bigger prism, and then I have the prism that is the smaller prism. Bigger prism, what is the volume formula? Area of the base times the height of the prism. Again, because these are rectangular prisms, you can just do the length times width times height. What is the length of the bigger one? It is 20. What is the width? So this measure right here, that tells us it is 6. So this measure is exactly the same as this measure, and both on them sides, so that is 6. What is the height of the larger? That is 4. Let's do the same thing for the smaller prism. This right here is, okay. So from all the way from the bottom to all the way to top is 11. However, we know what the height of the prism, the larger prism is, and that's 4. So this is 4. Then this means what? 7, 8, 9, 10, 11. So this means the height is 7. The width is 4. And the length, what is this length? We want to know what that measure is. We know that this is 15. So if I'm going to cut this down, we know that this is 15. So this means this section, I keep saying this a lot. I apologize for that. Is just 5. Again, the 15 was given to us. We cut the bigger prism down. We know that this section is 15. Therefore, the remainder is 5. Using our trusted calculator, I have 20 times 6 times 4. That is 480. I have 5 times 4 times 7. That is 140. What are we doing? We are combining because we placed one of the prisms on top of the other. So the total volume is 480 plus 140. And that is 620 units of measure is centimeters. What are we trying to find? Volume. Volume is cubed. All right, beautiful people, that wraps up our review for volume. Next up is surface area. If you have any questions or if you caught a mistake, please let me know. Thank you so much for watching, and I appreciate every single one of you. Enjoy the rest of your day, and I will see you in my next video. Goodbye.